In a typical home with one furnace and AC, changing the thermostat settings changes the temperature in every room of the home. To have different areas of the home at different temperatures requires manual or automatic zone control. Zoning means the selective heating or cooling of different areas in a business or home. Unused rooms can be left idle, while occupied areas can be heated or cooled as needed, thus saving energy. A simple form of manual zoning is to open or close the registers in each room based upon the demand, thus allowing the conditioned air to be selectively directed as needed. A common residential practice is to close basement registers during the AC season and open them again during the heating season. However, if the temperature demands change every day, then an automatic system is desirable. There are many options when it comes to zoning, with some practical solutions and quite a few impractical ones. For example, adding multiple extra furnaces and AC units is usually not the answer to a simple zoning problem. A common two-zone system from a single piece of HVAC equipment is to place the master suite on its own zone and the rest of the home on another. But because there is only one furnace and AC, the homeowner cannot simultaneously heat and cool the different zones at the same time. If every room is to have its own thermostat and simultaneous heating and cooling is required, the system becomes very expensive and exponentially more complicated. Let's start by focusing on the number of zones for a home. For larger homes with multiple furnaces and AC units, zoning is automatically accomplished through the use of separate equipment for each area. Each furnace and AC has its own dedicated ductwork running to different areas of the home, thus allowing for differential heating and cooling. Such a system would also allow for simultaneous heating and cooling of different zones. Such a system usually needs to be built into the home at the time of construction. A very common problem for multiple-story homes with one furnace and AC in the basement is that the upstairs is always hot in the summer and always cold in the winter. The ductwork runs are so long that by the time they reach the upstairs, the airflow is insufficient to deliver the correct volume of conditioned air. The answer is to add a second furnace and AC to the attic with ceiling registers delivering conditioned air to the space. The old floor registers from the basement furnace are permanently closed, and a dedicated thermostat installed on the top floor is used to control the attic furnace serving just the top floor. This home would then have two separate zones independently controlled using two separate thermostats. For new construction, a broad selection of zoning options are available, and they're also the easiest and least expensive to install. Let's discuss a home where there will be only one furnace and AC with 3 zones. Before the ductwork is installed, a decision needs to be made regarding what parts of the home will be covered by each zone. Once decided, separate ductwork is installed from each zone back to the air handler, where all the ducts join together at the plenum or main trunk. A zone damper is installed at the beginning of each separate run of ductwork to control the flow of air to that zone. 3 zones require 3 dampers. Since the operation of the damper cannot be seen once mounted inside the ductwork, we will demonstrate the control operation using the Zone Controls teaching station. Each zone has its own thermostat and each damper has its own damper motor. The 3 thermostat wires and the 3 damper wires run to a central zone control panel. Inside there are clearly marked terminals for each of the 3 thermostats and separate terminals for each of the 3 dampers. Each is hooked up according to the manufacturer's instructions. The zone control panel also has one equipment terminal to communicate with the air handler to regulate heating and cooling, and it runs directly to the control board in the air handler just as a single thermostat would. Let's now walk through what happens when the thermostat in Zone 1 calls for heat. The signal is communicated from the Zone 1 thermostat to the zone control panel, which does 2 things. It closes the dampers to the other 2 zones not calling for heat, and it turns on the furnace. The heated air then flows directly to and only to Zone 1, avoiding the other 2 zones completely. Now what if Zone 2 calls for heat while the furnace is already supplying heat to Zone 1? The zone control panel opens the damper to Zone 2, and the heated air now flows to both Zone 1 and Zone 2. Since Zone 1 called for heat first, it's likely the thermostat in Zone 1 will become satisfied prior to the Zone 2 thermostat. When this occurs, the furnace keeps running, but the damper to Zone 1 now closes, allowing all the heated air to flow to Zone 2. Once Zone 2 is satisfied, the zone control panel shuts off the furnace and returns the dampers to their neutral position. This neutral position depends on the type of damper and the brand of zone control panel being used. If Zone 3 now calls for heat, then the damper to Zone 3 will open and the other 2 zones will close and the furnace will start. As is obvious with this type of zoning system, it is not possible to simultaneously heat and cool different zones at the same time. So what if Zones 1 and 2 are already calling for heat and then Zone 3 calls for cool? Zones 1 and 2 must first satisfy their calls for heat. Then the system will purge for roughly 3 minutes by running the blower to remove any heated air from the ducts. At the end of the purge cycle, the zone control panel will close Zones 1 and 2, open Zone 3, and turn on the AC system to supply cool air to Zone 3. Anytime the system switches from heat to cool or cool to heat, it goes through this purge cycle. For a technician troubleshooting a system, there's a purge override button which eliminates the 3-minute wait so you don't have to waste time. If a home is large enough to justify the installation of a 3-zone system, the blower is likely to be large, probably 4 or 5 tons, which is 1600 CFM to 2000 CFM. This raises an interesting question. If only one zone is calling for heat or cool, won't 2000 CFM be too much air for one zone? Restricted airflow can cause duct whistling, and in the AC season it can cause the evaporator coil to ice up. The answer is the installation of a barometric bypass in the system, or to use a proportional zone control. If only one zone is calling for heat or cool, the duct pressure will be very high. A barometric bypass is set to open under such high pressure conditions, detouring part of the air back to the air handler. This relieves the pressure in the duct and allows for proper airflow across the coil. When more than one zone opens, the pressure is relieved and the bypass automatically closes. For a proportional zone control system, when only one zone is operating, the zone control panel partially opens the other zones to relieve the pressure. With top-of-the-line modulating furnace and AC equipment, neither a barometric bypass nor a proportional zone control is needed, because the equipment automatically adjusts to the appropriate output level based upon the number of zones calling for heat or cool. Many zone control panels have a safety feature called a duct sensor. This sensor mounts on the side of the plenum or main trunk and has a temperature probe which extends inside the ductwork. If a zone control panel comes with a duct sensor, it won't work without it. In the event of an overheated condition such as a furnace malfunction or house fire, all the dampers close and the equipment shuts off. This prevents the spread of fire through the ducts. There are 3 different kinds of damper motors which power the opening and closing of the damper itself. Power open, spring close, power closed, spring open, and power open, power close. Each must be wired in a different manner in order to function correctly. On the board are damper terminals dedicated to each damper motor, and each contains one common, one power open, and one power closed terminals. Which terminal is powered depends on which zone is calling for heat or cool. The power closed terminal is energized when there is an active call for heat or cool on another zone. The power open terminal becomes energized when there is an active call for heat or cool on the same zone. The power open spring closed damper means the damper is normally closed and must receive power from the zone control panel to open. It's wired to the common and power open terminals. If there's a power failure, a motor failure, or a board failure, the damper will automatically close and remain closed until the problem is solved. Such dampers are a good fire spread prevention method, but they block all the airflow to that zone until a repair is made. The power closed spring open is a normally open damper and must receive power from the zone control board to close. It's wired to the common and power closed terminals. This is the most common type of zone damper in use today because if the motor fails or there's a zone control panel failure, the zone will open, allowing the conditioned air to circulate. It is true that the control of zones is lost during such a motor or control failure, but at least every area will receive heating or cooling until a repair is made. For the power open, power closed damper, the motor is energized to open and to close the damper and is wired to all 3 terminals. There is an end switch which cuts off power to the motor once the damper has reached its full open or its full close position. If the motor fails, the damper remains in its last position until a new motor is installed. Let's discuss the hookup of damper motors in more detail. A power open damper is wired to the power open terminals. A power closed damper is wired to the power closed terminals. A power open, power closed damper is wired to both the power open and the power closed terminals. Some manufacturers like Honeywell name their terminals differently, but these new terminal labels match the equipment labels on the dampers to make it easier to install. If you look at the schematic, you'll see that they still identify the terminals as power open and as power closed. So even though the names are different, they function exactly the same as every other zone control in the world. The schematic also shows you the proper hookup for any type of damper configuration. Power open, power closed, power open, power closed. Notice again which terminals are energized. The power closed terminal is energized when there's an active call for heat or cool on another zone. For example, If there's a call for heat on Zone 1 and you're using the power closed dampers, which are normally open, the other zones activate their power closed terminals in order to close the dampers on the other zones not calling for heat. On the same call for heat in Zone 1, the power open terminal becomes energized on that zone. So if you're using power open dampers, which are normally closed, then Zone 1 will energize the power open terminals, opening the damper for Zone 1 and only Zone 1. As is obvious, power open, power closed dampers have to be energized in order to open or to close the damper. This same configuration opens the Zone 1 damper, but it closes the dampers to Zones 2 and 3. Inside the zone control panel is a dedicated power terminal from an externally installed transformer. The transformer inside the furnace is usually insufficient to power both the air handler and the zone control panel, thereby requiring the installation of a dedicated transformer just for the zone control panel. This means that there will be two separate 24-volt power supplies going to the zone control panel, one from the air handler equipment and one from the dedicated zone control panel transformer. Care must be taken to keep these two sources of power separate from each other, since they may be out of phase with each other. The question arises of what to do with existing construction when the ductwork is inaccessible or improperly configured to allow for the installation of dampers in the main duct supply. There is a special type of zone system which controls the individual registers in every room of the home. With this system, a thermostat is installed in every room, and every register is replaced with a motorized register which opens and closes depending on the room temperature. Either a tube or a wire runs from each register down inside the ductwork to the mechanical room, where it exits the ductwork and is connected to a special zone control panel. The zone control panel then activates the heating and cooling functions as required to meet the individual needs of each room. A multi-stage furnace is highly recommended for this system. As with all conventional zoning systems, you cannot simultaneously heat and cool. Radiant floor heating systems are always zoned to allow for individualized control. The zone control panel is essentially the same as with convective heating, except that a solenoid valve or pump is being controlled instead of air dampers. Electric baseboards in every room inherently allow for individual temperature control. With radiant heat and electric baseboards, only heating is possible. An extremely expensive system called the City Multi moves heat around inside of a building, allowing every room to be at a different temperature, and it simultaneously heats and cools. These units are only found in commercial buildings or in the most expensive luxury homes. Literally, if the south-facing rooms are getting warm while the north-facing rooms are getting cold, the City Multi moves the heat from the south to the north in order to maintain the desired temperature at any point in time or during any season of the year. If excessive heat is being generated within the building overall, the system removes it to the outdoors using air conditioning technology. If not enough heat is being generated internally within the building, the system injects heat from the outdoors using heat pump technology. Each room has a temperature sensor, and control is maintained through a centrally operated computer program. Mini-splits are a unique class of HVAC equipment allowing both heating and cooling through a single room head. The heads can be mounted inside the ceiling, on the wall, or at the baseboard. The outside unit can service anywhere from 1 to 8 heads, but only single-room mini-splits allow for simultaneous room-by-room heating and cooling separate from all other zones. In this regard, individual mini-splits work much like the City Multi system we just described, but they don't move heat around within the building. A multi-split serving more than one room can only operate in the heating or in the cooling mode at any given time. All heads must be set to heating or cooling, otherwise an error code will be displayed. The single most efficient cooling system in the world is a single zone mini split with efficiency ratings in excess of 33 SEER. With efficiencies over 650%, they raise a question of how any piece of HVAC equipment can operate over 100% efficiency. The answer lies in the fact that heat pumps do not create the heat, they simply move existing heat from the outdoors to the indoors. In other words, for every watt of power they consume, they generate over 6 watts of heat inside the structure. They also work to negative 15 degrees Fahrenheit. When people hear this, they often say that there's no heat in air at negative 15 degrees. With absolute zero at negative 460 degrees, minus 15 degrees is actually quite hot. Literally, there are trillions of BTUs of heat in the air at that temperature. You simply need specialized equipment to remove the heat and move it indoors. Single or multi-split systems inherently offer zoning, allowing every room to be at a different temperature, and with single zone mini splits allow for simultaneous heat and cooling. For special applications like a theater room in a home or a computer room in a business, it's recommended that a dedicated single zone mini split be installed in these locations, which will require cooling year-round. In conclusion, zoning can be retrofitted to any building or home, although the installation at the time of construction is best. Systems which can simultaneously heat and cool are the most expensive and complicated, but simple zoning systems using existing HVAC equipment are inexpensive and easy to install. Heating only and cooling only systems are available, but most systems allow for both. Zoning does save energy, which will pay for the equipment over time.